learning objective is number one, two cylinder sequence circuits. That is, there are two cylinders which we have to control. Pilot control valve operation, indirect pneumatic control system, and the circuits A plus B plus A minus B minus A plus B plus B minus A minus and A plus B plus and simultaneously A minus B minus. And the last objective is cascading. So this is very important for learning the sequencing of this pneumatic, because last lecture we have seen that is A plus A minus is nothing but a control of single cylinder. Now here two cylinders are there, first one, and after that we have to control the sequence also, means in what sequence the extraction and retraction will occur, that we have to control depending on the application. Now you will be wondering that what is this two cylinder sequence circuit, what is its application, and where we have to do this. So for you I have downloaded one application wherein this is a small application of stamping. That means here there are products that to be stamped by using this cylinder. And there is some date stamp, name stamp, whatever it is. You have to stamp it on every product. So that product needs to get here. Then the stamping should be done, and then it has to be pushed out of the system, so that every time this will be done automatically unless it is stopped. Okay, because this is a stacker wherein all the products will be stored, and once this is finished, suppose this is a lot of 50, so 50 finished, then we can refill with new stock. Okay, so for 50 cycles this will run automatically without any human interface. So that is nothing but the automation process. So herein only we are using our sequencing. So this is completely a pneumatic system. You can see here that there are pneumatic cylinders, three cylinders are there, and here there are the product. Actually this is electro-pneumatic because you can see that here there are sensors, but pneumatic also the same system can be rebuilt, but the logic remains the same whether it is electro-pneumatic or whether it is pneumatic or hydraulic. Okay, so to understand this application, so what we have to do, we have to just push one product at a time at this location, then we have to stamp that product, and then this stamping cylinder will go back, and then this pushing cylinder will push the part out. So this is the simple application. So here basically there are three cylinders. So sequence depends on the user. Suppose if ignore that somebody will be there who will be continuously taking out the finished product, then there will be only need of two cylinders. So in that case, whatever our application is, that is A plus B plus A minus B minus, that can be fine. So let's see that A plus B plus. A plus means what? This, so suppose this is cylinder A, this is cylinder B. So A cylinder will push the part in A plus stroke. So A plus, then B plus. So stamping is done. Now B minus will be done, so the stamp can be retrieved, and then A minus will be done, so that it will be ready to again push a new part in the place. Okay, so A plus, B plus, B minus, A minus. This can be other way also. So that is A plus, B plus, minus, B minus. It will stay there up to certain time and then it will move out. So this is how, and it totally depends on what is the sequence of operation you want to do, and that only has the control on it. Okay, so let's see how this circuit can be prepared. So most important part in this sequencing is that our next objective is two cylinder sequence circuit pilot control valve operation. Yes, we have to understand what is pilot operation, because till now we have not explored this option. This is nothing but the actuation of the valves with the help of pilot signal. Now this pilot signal is nothing but a compressed air, that is a pneumatic air signal. This is a pneumatic signal. That means how I have configured this, just double click on it and you will see here that the actuation in left and right is through pneumatically or electrically. It means this is nothing but pneumatic supply, compressed air. You can see this symbol is nothing but for compressed air. So this is pneumatically actuated on both the sides. Okay, so that means how this A plus going to happen? A plus going to happen only when this symbol, this line is connected to compressed air and it push the piston position, wall position to the actuated position, and then this one will be connected to 4 and you will get A plus. So similarly, if you want A plus, you have to actuate this line. If you want A minus, you have to actuate this line. Similarly, for cylinder B, this is cylinder A, this is cylinder B. So for B, there is also the same logic, that is B plus and B minus. When this left actuation is done, then it is moving forward. So this is B plus. And when right actuation will be done, then it will be B minus. Now we have to control that. What is our sequence? Sequence is A plus, means the movement of piston from A0 to A1, A plus, then B plus, then A minus, and then B minus. So this is only we have to control. Now, what are the components needed that we should know so that we can build a circuit? Now it is very simple, that there are, from this question itself you come to know that how many cylinders are there that we have to control. There are two cylinder, one is cylinder A and other one is cylinder B. So we need this component, that is two double acting cylinder we need. In last lecture we have used single acting cylinder because there is only one motion. Here it is to be controlled and it is to be stayed at that point for certain time unless the other operation is finished. So here we will use two double acting cylinders. So these are the two double acting cylinders with limits of A0 and A1. Labels are A0 A1 and B0 B1. These are nothing but the roller switches which is employed over here, and below you can see the roller switches. Okay, now so two cylinders will be controlled by one direction control valve. So two cylinders, so two control valves. So two cylinders, two control valves. That may be either 4x2 or 5x2 depending on the use. So final DCV number 2. So here 4x2 valves I am using. So these are nothing but the two direction control valve. Now these direction control valve are pneumatically piloted. That means it has to be given supply through certain switch so that it can be made on. So if A plus I want to make this switch shoot on. So this is nothing but it is a roller switch. It is nothing but a roller switch. That means when I want A plus, I want to actuate this. This should actuate and then I will get my A plus. Similarly, this wall will be actuated. Then I will get B plus, and then this one I will get A minus, and then this will provide me B minus. Okay, now how to decide which are these walls? That is the trick, is very important, that I'm going to share with you. So this two walls have two pilots, so two pilot has two roller switch. So how many walls? Two walls, two pilot switch. So total four switches we want, that are nothing but the 3x2 pilot, 3x2 roller walls. Okay, 3x2 roller spring return. This is 3x2 roller spring return walls. Means once this position is gone, when this roller switch is gone, then it should regain its original position. Okay. Now this to start. So these are the basic requirement of our twin cylinder control, twin cylinder sequence control. Okay, so now to start this we need one push button 3x2 switch, which will be started by using the manual actuation method. So this is only manual actuation, otherwise everything is roller actuated. So this is A0 A1 are roller switches. These are the switches, but we don't know that whether this is A0 A1, this is B0 B1. No, that depends on the sequence of operation. That is the trick, that to label this uh, roller switch according to the sequence. Okay, that I'm going to share just now. So how the signals are coming? So compressed air through air filter unit or air service unit, it goes and it stays at point 1 and it doesn't go forward, so that this will be active as a start switch. We can say that this is nothing but, I will label it as start switch. So this is nothing but start switch. This is nothing but your start switch. So start switch is this. So user will have this one switch so that it can press and then the cycle continues. Okay. So now the most important part, that is the trick for setting these roller switches so that we can get the operation. Now if I start, what will happen? The compressed air is here. Nothing is happening. Once I push, the compressed air comes to 1 and this will now, if it is on, then only our compressed air goes to this side of the wall actuation and A plus can occur. So I want that this this should be on when I push this start button. Now what is the condition by which I will make it on and what is the condition that I will make it off? That is nothing but the sequencing. So how to decide that? It is very important and there is a trick for that. So let's see the trick. Now here what we want is A plus B plus A minus B minus. So the trick is just make a cycle. How the cycle is? A plus B plus A minus B minus, and again it repeats with A plus B plus A minus B minus. Okay, so to have the actuation of A plus, something is there, that operation needs to be finished and then only A plus should start. Okay, so for A plus to start, its previous activity is nothing B minus. So how we will come to know that B minus has been finished? When this cylinder, this piston B reaches B0. Okay, B minus means what? The motion of piston from B1 to B0. Okay, so the previous operation to A positive is nothing but B negative. So B negative will be finished when it reaches B0. So what is the starting point for A plus? A plus starting point is nothing but C. A plus starting point is nothing but B0. Okay, is it clear? Once again, we will repeat it so that you can apply it to next logic. So A plus, previous activity B minus will complete when the piston reaches B0. So B0 is nothing but the actuation wall for A plus. Okay, now we want B plus. So B plus, before B plus, previous operation is A plus. When will A plus will finish? A plus will finish when it reaches A1. So what is the prerequisite? Prerequisite for B plus is nothing but A1. Clear? So similarly, A minus, we need A minus. So previous to A minus, what is there? There is B plus. So B plus, when it will be finished? When the piston B will reaches B1. So once it reaches B1, then only A minus should start. So this prerequisite for A minus is nothing but B1. Similarly, can you tell me for B minus? So let's see. B minus, previous activity is A minus. A minus will finish when the piston A will reaches A0. So now let's have this actuation as A0. See, these are nothing but, these are the roller switches. These are the roller switches or sensors, that pneumatic sensors that we are employed in the path of this piston movement or piston stroke. So for A plus to be completed, we need the actuation should be B0, for B plus A1, A minus B1 and B minus A0. So you have to just see that this is ready with you. Now your circuit is ready. Now according to the sequence, what I want A plus, what I want A plus. A plus will occur when B0 will be on. So just label this as B0, right? So if B0 is on, this will be working. Now next, I want B plus, the condition is that A1. So where is B? B cylinder, B plus here. So its previous wall will nothing but this is A1. Okay, clear? Means what we are doing for A plus we need B0, for B plus we need A1. Now similarly for A minus we need B1, for A minus we need B1. So let's give this as B1. And next for B minus we need A0. B minus we need A0. So A0. So this is the trick behind the labeling, and this is made your work very easy so that you can easily recognize what walls to be on and off, because this is the most confusing thing in pneumatics is sequencing, wherein you can't decide that which operation will be going to occur when you activate certain switches. Okay, so now I have given you the logic, apply that and make the further logic. So now this is a time that we should check whether our logic is working or not. So what we want A positive, B positive, A negative and B negative. So let's check once. So here the compressed air will come and the supply is over here. When I push the start button, the supply comes here. Now here see, the B0 piston is at B0 position, so this is activated. This is already activated, so B0 is reached, so it is already activated. So once I push start button, the compressed air will flow directly into pilot signal, and here this when this pilot signal comes, A positive should occur. So this position comes here, and the compressor supply one is connected to 4, and from the cap end of the piston the air comes and the piston will be forced to extract. Now as soon as this piston extract, this A0 position goes and it will come to A1. It will come to A1. So once it reach A1, what should happen? Once it reach A1, this A1 wall will actuated. Means when this complete A plus, A1 will reach, and when A1 will reach, this wall will actuated and this supply will be now given to B plus part, and now this will come here and compressed air will go to the cap end of the cylinder, and the B cylinder will start B plus operation. So A plus finished, now B plus, and similarly A minus and B minus. Okay, so let's check the simulation in slow motion so that we can visualize the operation. So let's start. Okay, yes. Now here you can see our simulation started. So these are the pressure lines which are shown. So currently on the rod end side the pressure is applied, so the both pistons are retracted motion, and A0 and B0 is on. Let's check it out. A0 is on. So where is A0? A0 is on. So see this power supply is connected. So A0 is on. Yes, B0 is also on, so this is also connected, but here there is no supply because we have not started the switch. So compressed air is not reaching to this point, but this is already connected. One is already connected to 2, and A positive can start at any moment when we push our start switch. Okay, and most important thing is that what is the advantage of piloting? Piloting advantage is that if it requires very less pressure, pilot is require very less pressure as compared to the operating pressure. So small pressure can be used to actuate these valves, and the operating pressure will be fully given to the cylinders so that there should not be any leakage or wastage of our air pressure. So this is very important that this is piloting sequencing. Okay, so let's start this switch. See, A positive, B positive, A minus, B minus. Okay, so this is a single cycle wherein we have completed our A positive, B positive, A negative and B negative. So this is how these circuits are made. Surely practice this, you can easily make this. So let's move to the new circuit. I hope you understand. So let's see once again. I will repeat this. Okay, so one cycle is complete. Now this is a single cycle operation. Now this is a single cycle operation. What if I want a multi-cycle operation? The simple way to achieve multi-cycle is that using this detent switch, push button and detent switch. Detent switch, the meaning of this, it will remain at that position unless it is pressed again. So you can take it as a toggle switch. Once you push, it will be on, and when you push it again, it will be off. So toggle switch you can take it as. So let's have a cycle. So previously we will push once, one cycle completes and the system stop. Now here we have applied the detent switch. So once we press this motion start, and this will continue for multi-cycle. So let's check it once again. So start our simulation. A positive, B positive, A negative, B negative, again A positive. So now you can see that this will continue unless I stop this supply of compressed air by pushing this toggle switch. So that depends on user, that whether he wants a single cycle or whether he wants a continuously moving cycle, that is multi-cycle operation in the same application. So this is very easy and I hope you understand. So let's stop this, and when I stop this again, after one cycle it will stop, as every cylinder has its own pressure supply. Okay, so this is how A positive, B positive, A negative, B negative works. Now next circuit is very important for us to learn. Now what logic we have applied, the same logic we will use for the next circuit, and I will tell you the physical issue with that. So I want you to now, let's see and apply the trick to next part of this circuit. So next configuration or next combination. So previously we have done it for A positive, B positive, A negative and B negative. Okay, now the position is changed. Now the sequence is A plus B plus, as similar to the previous one, but now instead of A minus we are having B minus, and then there is A minus, then there is A minus. So here A plus B plus B minus A minus. So likewise many combination can be done, which you can study at home. So A positive, for A positive now apply the same logic. For A positive, previous to A positive, which is there, A negative. So to complete A negative, which roller switch should be on? It is nothing but A negative. A negative means retraction. Retraction means A0. Retraction will be finished unless it reaches A0. So A minus will finish only when it reaches A0, and when it reaches A0 we need A positive to be start. So again when it reaches A0, A positive should start. Now what about B positive? Before B positive, A positive is there, so A positive will finish when it reaches, yes, A1, right, it reaches A1. So here A1. So once it reaches A1, that means A plus is complete, and after that only B plus should start. And after that B minus, previous to B minus there is B plus. So B plus will finish at what point? B plus will finish when B1 is reached. So prerequisite for B negative is B1, and A minus, previous to that B minus, and this is nothing but B minus will be finished when the piston reaches this roller switch, that is B0 is on. Okay, so this is how it is going to change. So by just changing the walls, you can get a new sequence. Now let's check whether this trick works or not. Actually, this is working, but let's see whether it is working with pneumatics, our general diagram, or we have to do certain modification. So there is basic problem that will arise, and I will give you the solution for that. And it is very important to understand in pneumatic that how the fault finding is to be done, because the only fault comes in this is the pressure. Means if there is a pressure from both sides, this wall will not change the position and it will stay somewhere in between. Are you getting me? That means if A plus signal is on and A minus signal is on, then there will be no movement. So it is very important that when you are using pneumatic or electro-pneumatic, the signal should be given to only one side of actuation and not the both. If both signal comes at a time, there is no actuation, and that is the major fault in pneumatic circuits in industry, and it has to be rectified. Okay, so let's see what is our logic for this. Here we want A plus A0. Here we want A plus A0 and B plus A1. So we want this as A plus A0. Okay, and we want B plus A1. So where is B plus? B plus is A1, correct. B minus B1. So where is B minus? Here is B minus. So B minus will be now labeled as B1, B1, B minus B1, and A minus B0, and A minus B0. A minus, we have to label it as now B0. So this is our logic, and let's check whether the same logic can be applied to this circuit or not. If not, then why? So now this wall logic we have already applied, and let's see whether it is working. So starting the simulation. Okay, yes, and push button, and see nothing is happening. So are you rectifying the problem in this circuit? Nothing is happening. I means after pushing the switch also there is no motion. We need A positive, B positive, that should start immediately when I push the start button. So here the pressure switch is there. So here pressure is coming, and you can see that what I have just told, that both pilot switches having pressure, because A0 is also on and B0 both are in retracted position, so both valves are on at the same time. So because of this there is no change in the position of the valve and there is no motion of piston. So this is a major fault in such kind of circuit. So there is a thumb rule for this. Let's understand this. So logic behind these walls is same, remains unchanged, but here basically whenever such kind of circuit are there where you can see that there is a simultaneous contraction and retraction, simultaneous contraction, extraction and retraction is there, then we cannot use this logic. We cannot use this logic. See here why I'm saying this. A plus, then B plus, then same cylinder B minus. So you see that if we want this two to be simultaneously on, so this will not, we have to change the supply, we have to change the supply. So this kind of circuits wherein there is a extraction and retraction simultaneous, or you can say consecutive extraction and retraction of the same cylinder is there, then this technique of making this logic control is not there. We have to use certain different technique, and that technique is called as cascading. That technique is called as cascading. So how to do that? I will tell you, and we will make this circuit A positive, B positive, B negative, and A negative. This is very important because see, if any combination you are going to do, this combination will come, and if this comes, then this logic doesn't support that. So how to do that? Let's see. So before starting, it is needed that you should divide this two set. You should divide this in two set, means in one set A positive and B positive will occur, and other set B negative and A negative will occur. So that's why you can see here I have given one separator over here, so that I have bifurcated these two sets, A positive, B positive in one set, and B negative and A negative in another set. So let's start making that circuit. So here you can say this is A positive, B positive, B negative, and A negative. So now wall diagrams are here, and component, all the components I have already taken so that our time will be saved. So here we are learning about cascading. Here we are learning about cascading. You can say that this is nothing but it is cascading of pneumatic cylinders. Cascading of pneumatic cylinder. So this is cascading method. It is also very simple, just logic to be remembered. So as logic applied here for A positive, A0, B positive, A1, previous one is to be complete. Now this bifurcation we have done, and because of this bifurcation there is a need that we should have two supply lines. One supply line is for B positive and sorry, A positive, B positive, and another supply line for B negative and A negative. So this switchover will serve our purpose of getting consecutive extraction and retraction of the same cylinder, because you can see here that S1 is responsible for B plus and S2 is responsible for B minus. So if B plus and B minus simultaneously is on, then also there is no issue because these supplies are changing. So if S1 is on, then S2 should be off. So that's how we are going to make sure that both actuation should not be on at the same time. So now again, what are the components required? As you can see, there is two cylinders, so we have taken two double acting cylinders. These two double acting cylinder will be definitely controlled by 4x2 walls. Both are pilot controller as seen in the previous applications. So two walls. After that, there are, you can see there are four switches: A0, A1, B0, B1. So I have taken A0, A1, B0, B1. So four switches I have taken. One start switch I have taken, and this is changeover wall. This wall is for changeover of supply, means this shifting from S1 to S2 should be the changeover supply. Now who will change over, how that can be achieved, that I will show you. This A plus B plus B minus A minus. Now let's see, this A plus will be done after A0. Okay, because A minus will finish when A0 is reached, and after A0 we should start A positive. So now this group, this is A plus B plus, is powered by this supply S1. A plus B plus is powered by supply S1, and B minus A minus is powered by supply S2. Okay, so we have these two power supplies. So once we have to make S1 on so that A positive should start. Now to control this changeover of supply, again we need a extra 4x2 wall. So this will responsible for shifting the supplies. So first we will draw the circuit for A plus. So A plus we need A0. Okay, so we will take A0. So this is responsible for getting our A positive supply. So A0 I have taken. Now before A0, how this is a start of a circuit. So before start of a circuit, we always use a start button. So this is not the start. So this push button is nothing but our start button, and through this start button we will supply our pneumatic pressure. Okay, so take one compressor, and let's attach this to our one point. And now this is exhaust to the atmosphere, so no issue. Now once this is connected, when we push this button, we want that this pressurized air should go to A0. Now, is you can see here that A0, that means this cylinder A is already in a retracted position. So A0 is already on. So you have to just connect this two part to 1. Now you can see that your push button is connected, your start button is connected, and when I push the start button, this compressed air will flow. And if this A0 condition is met, then that means before A plus, what is the condition? A0 should meet. So before the start of a circuit, we should check that whether this is A0 is reached or not. So this is a checkpoint. So this is the AND logic. If you see carefully, this is nothing but AND logic. AND logic, what it says, that when this is on and this is on, then only the switch is on. When this is 1 1, then only 1, otherwise 1 0 0 1, everything is 0. So once you push the button, this is in series, so AND circuit is there, and this 2 is now connected to this. So we can set when this end is connected, this end is powered, this end is powered, what we want? We want A plus to be powered by S1. So when this happen, what is there, that compressor is now again connected to the source, that is pressure source 1. Now in this position, when this S1 is there, when this S1 is powered, so we can say that this actuation is for S1 and this actuation is for S2. So we can say this is for S2. Okay, now we will see. So A0 is responsible for A plus. A plus and B plus are powered by S1. So when this S1 comes, this 2 should connect it to our S1 supply. That means now when I push the button, this power source is connected to S1 and this S1 line is powered up. S1 line is powered up. Now I want A plus to be connected. So A0 is now connected, now S1, and because of S1 A plus will occur. Means the sequence is A0, because of A0 S1 will occur. So if you want, I will shift this thing here and like this, so that the sequence also be seen in the same way. A0, then S1, S1 to A plus. Okay, A0 to S1, S1 to A plus. So A0 to S1, this S1 is powered, S1 to A1. So this line is connected. Now what will happen whenever you push the button, this power source is connected. See, A0 is already on, so it is acting as a pilot supply, and this position will comes into picture, and in that 1 is now connected to 2 and 2 is connected to S1. So S1 is in power. Now what happens to 4? 4 is connected to S2. 4 is connected to S2. That means whenever the shift occurs, 1 is connected to 4 and 4 is nothing but S2. Okay, so the changeover will occur when this S2 switch will come. So let's start. So this we have done the circuit diagram for A plus. Now we want B plus to be started. Now again this B plus is also powered by S1, so B plus should be connected to S1. But if we directly connect it to S1 like this, what will happen? See what I have done. As I am saying that S1 is connected to A plus and B plus, so S1 is connected to A plus and B plus. So if I do this, what happens? Whenever I push this switch, the A1 and S1 supply is on, the motion of A positive and B positive will start simultaneously, which we don't want. What we want that where first A1, sorry, A plus should start, and when it reaches A1, then only B plus should start. Okay, so this A1 is a key between this actuation. So what we have to do, we have to just add A1 switch, because we know that B plus is the responsibility of A1. So A1 roller switch should be added over here, so that it can be connected to, it can be connected to S1, and later on the 2 point is connected to B1. Now see how the circuit will work. Push button, S1 will be on, then power supply S1 will be on. So this S1 is connected to A positive, so A plus will start immediately. And when it reaches A1, because this line is powered up, so the power supply comes to at 1 and it is stopped over there. Unless the A1 switch is on, it is not going to pass through, means one is not going to connect to 2 unless A1 is reached. So what we have done, sequencing. So first A positive will be occurring, and when it reaches A1, this S1 is now connected to B plus, and B plus will start. So understood, this is very simple, but it has to be logically understood so that it can be repeated. Okay, so now what we have to do, we have to give the individual power supply to these walls, because they are individual units and working on that. Okay, so you can see here, whenever yes, so what we have done, A0 to S1 and S1 to A plus will finish when A1 is reached, so A1 is connected in between B plus and S1. Okay, now after this, that means one set is over, that A plus is over, B plus is over. Now what we have to do, now we want B minus and A minus, but remember that before going to B minus, there is a need that we have made a subset, that S1 supply now switch over to S2, means S1 should be now shifted to S2. So this changeover we have to done, means previously A0 is on, so S1 is on. So now we have to cut off this S1 and we have to start our S2. Now we have to start our S2. So for S2, we have to make arrangements so that S2 will be powered up. So how to do that? Now we know that this switching and B minus, to achieve B minus, what is the previous condition, that B1 should be responsible for B minus. So we need S2 to be powered through B1 and it should start our S2 circuit. Okay, so how to do that? Take B1, take B1 take B1 and give the supply, take B1 and give the supply from S1. What we have done, we have taken the supply from S1. Now because what we have to do, once this is on, this pressure source of S1 should be cut off and then it is connected to S2. So this is just acting as a signal, acting as a switch. So once it is on, his work is over. Okay, so this once B1 is reached, its work is over. And what it will do, B1 will be on and this 1 point is connected to 2 and 2 is connected to S2 as an pilot supply. So whenever this whenever this B plus occurs and B1 reach, this B1 will be on and S1, a compressed air through S1 will now pass as a pilot signal to S2. Now here, once A plus is on, when A plus is done, this is cut off now. This A0 is cut off and the position is not there, means supply in there is no supply in this switch. So this S1 is cut off so that we can power S2 anytime. So we have taken from S1 and it is just for switching the supply. So we have given the supply, and this end we have already exhausted to atmosphere. Okay, now post B1, what should be occur? B minus. What should be occur? B minus, and B minus and A minus are done through supply S2. So now when this supply S2 is on, this B minus should occur directly. So B minus should be connected to the supply. B minus should be connected to this supply, so that we can get our B minus operation. Okay, so S1 A plus, after A plus A1, after A1 B plus, after B plus B1, and because of B1 there is a change in power supply from S1 to S2 through this wall, and now S2 is powered, and when S2 is powered it is connected to B minus, and B minus occurred. Now after B minus, what we want? We want A minus. So for A minus, B0 is responsible. So what we will do for this S2, this B0 will be the precondition, or you can say actuation signal. So it is connected to S2. It is connected to S2, but it will on only when this B minus is completed. It will on only when this B minus is completed. So we will connect this to our port. So now you understood that we need B minus, so it is directly connected to S2 through B1. We need A minus, it is connected to S2 through B0. Okay, so this is how this cascading will be done. Cascading is very much important because this kind of problems wherein the consecutive extraction and retraction of the same cylinder is there, it is not possible to achieve by our general logic. So cascading is done. So let's see that whether we have connected all the components, all the pressure switch, exhaust switch, pressure switch and exhaust switch, and let's see whether it is working or not. So first we will run it in single cycle, and then it will be run in multi-cycle. Okay, so let's start. So let's see the option whether it is in slow motion. Yes, the same. So this is the initial cycle going on, and the circuit will stabilize. Yes, it has been stabilized, and now nothing will happen unless we push on this switch. So once we push this switch, see the operation should be A plus B plus B minus A minus, A plus B plus A minus, sorry, A plus B plus B minus, and then A minus. Okay, so let's push our detain switch. A plus, now it's B plus, B plus, switching the supply, switching supply, B minus, and then A minus. So this is how our cascading works. And as this is a detain switch, it is working in a multi-cycle mode. So this is multi-cycle mode in which it is continuously doing the same operation unless it is stopped. So see how the switching is done from S1 to S2, and at a time two cylinders are controlled and the sequence is properly done. So this is nothing but the cascading. So this logic can be continued for any number of cylinders with the same logic. So if you want, if there is a third group, so this is, there are two groups, so we have made two supply lines. If there are three groups, then we have to make three supply lines, and accordingly we have to switch over from 1 to 2 and 2 to 3. Okay, the same way means S1 is responsible switching on S2, and when S2 is switch on, S1 should be switch off, so that no two pilot line will be actuated at the same time. Okay, so thank you.